Hello, good morning students. Welcome back to chemistry online classes. See, in the previous class, students, I covered study that is ozone, right? Structure of ozone, its properties, that is oxidizing properties, bleaching action, right? Even we understood the other drops of the sulfur, that is aromatic sulfur, monoclinic sulfur, right? Even ground ring structure, and even S6 form, that is cyclo-chain form, and S2 forms. And then later sulfur dioxide also have completed yesterday. Only one last part remaining of the 16 group element is manufacture of sulfuric acid by contact process, that is sulfuric acid. Okay, this is also actually for your theory syllabus this has been deleted, especially the process. Okay, the flow sheet diagram is totally, they have deleted for only for theory, remember, but for me they have deleted, there is no other choice. That's why I'll explain it, but at the last in the notes, while giving printed notes, we will just write at the back which is deleted for theory and which is you have to read. All the syllabus are compulsory for date, there is no any choice for date. Only deleted syllabus for theory you write at the back side of your notes. Okay. Right, now what, not much wasting the time, let us discuss manufacture of sulfuric acid by contact process. Manufacture of sulfuric acid by contact process. Okay, actually it was 4 steps. Number 1, production of sulfur dioxide, SO2. Okay, and the second, purification and oxidation. Purification of SO2. Third, purification and oxidation of sulfur dioxide to sulfur trioxide. Okay, right. Next, after this, absorption of SO3 form dilution of oleum to get desired concentration sulfuric acid. Okay, and these are the 4 steps. I will tell you one by one. Okay, students, see, in this particular, that is production of sulfur dioxide, the production of sulfur dioxide, first step, I already told you, this sulfur dioxide is formed by combination of combustion SO2 gas. By combustion we can get sulfur dioxide gas. Okay, by combustion, direct combustion of sulfur. Not only this, using the pyrite burners. The combustion of pyrite burner, that is FeS2 on combustion gives ferric oxide Fe2O3 and liberates sulfur dioxide SO2. Okay. See here, for direction equation generally we have to end by heat and that method 4FeS2 2Fe2O3 iron will become balanced. Later, see 8 atoms are there, therefore 8 SO2. Lastly, 16 plus 6 22, therefore 11O2. Okay. And like this, ferric oxide and sulfur dioxide will get it. These are the 2 sources, 2 ways by which you can get what? Sulfur dioxide. This is the first step. Compulsorily have to write it. Okay. That means by combustion of sulfur and by the combustion of pyrite burners, that is ferrous sulfide is called pyrite burners. Iron pyrite is ferrous sulfide. Okay, this is the first step. Next step, actually, this sulfur dioxide is impure. It is made pure by passing through number of purification units. That is deleted. Actually, that is a very lengthy process which is deleted for your syllabus. The purification, just I will tell you. Purification of SO2, sulfur dioxide. First, this sulfur dioxide is passed through, okay, dust chamber. There, suspended dust particles are dissolved. Then it is passed through, okay, cooling purge, because at a very high temperature we are passing SO2. So cooling purge, here suspended dust particles and water soluble impurities are removed. Then it is cooled. After cooling purge, it is passed through dryer. There we will pass here concentrated sulfuric acid. That means this in the dryer it will absorb moisture, H2SO4, because it is itself acts as dehydrating agent. After that, it is passed through arsenic purifier. Which is a very important related to poison for the sulfur dioxide. Okay, to remove that arsenic purifier. Okay, this is here we will just place with a ferric hydroxide salt. It is positively charged salt. Arsenic sulfide As2S3 is negatively charged salt. They coagulate, mutual coagulation takes place, and the arsenic oxide is removed by just what ferric hydroxide salt cells are there. It will absorb. Then it is passed through. That is then to whether it is purified or not, to test that. It is passed through what? Tyndall box. Remember, Tyndall box. See, what is Tyndall effect? Scattering of light by the colloidal particles. That's only when the light is passed through this Tyndall box. If the light is observed, that is due to scattering of the suspended dust particle. If light is invisible, gas is pure. If it is not pure, you have to once again unit all this. Dust chamber, purifier, dryer, then arsenic purifier. Once it is invisible, then it is absorption. Okay, absorption. SO3 is absorbed where? In absorption tower. So once it is purified, now this sulfur dioxide is oxidized to oxygen. That is where in a catalytic converter, there is packed with the vanadium pentoxide or platinum as a catalyst heating to about the 720 Kelvin temperature. Okay, there you will get SO3. That means sulfur dioxide. This sulfur dioxide is where it is absorbed in absorption tower. What is that absorption tower? It is absorbing once again H2SO4 to form what? Oleum. H2SO7, that is oleum. And that oleum is diluted upon dilution in the water and get the desired concentration of sulfuric acid. This is actually the flow sheet diagram for purification up to here. Then further process I told you that I will once again explain. Okay? That means once the sulfur dioxide is produced, it is containing mainly arsenic oxide as a catalytic poison to purify that first dust chamber, any suspended dust particles or water soluble impurities are removed. Then it is cooled. Once again passed through dryer, where it is dried by using concentrated sulfuric acid, moisture is removed. Then it is passed through ferric hydroxide cells, where arsenic oxide is removed, and it is tested. If light is observed, impure. If light is invisible, it is pure. Then further it is passed through converter, where it is heated with vanadium pentoxide, which is easily available and cheap. Platinum is highly costly. That's why vanadium pentoxide is preferred over platinum. Heated over 720, sulfur dioxide is oxidized to sulfur trioxide. Then it is absorbed not in water, because it will form dense acid fog. And sometimes highly exothermic reaction, the production plant may explode. To avoid that, it is passed through once again through the flint glass sulfuric acid. This is already prepared laboratory grade. This is another one method, and that is already prepared one. So don't confuse, because we are manufacturing sulfuric acid, generally question arises, sir, where does this will come? That is produced by another alternate method, remember. Okay, right. Now this is from oleum. SO3 plus H2SO4 gives H2H2O7. It is called pyrosulfuric acid or oleum. That oleum is diluted with water to form what? That is desired concentration of sulfuric acid. 2 moles upon dilution with water. That I will show. Right? Remember, in purification unit, you are lucky. They have deleted this only from your NCRT theory purpose. But for NEET and CET, you have to remember. Okay, this is second step. Then third one. Third step is what? That is only oxidation. This is very important. Oxidation of sulfur dioxide to sulfur trioxide SO3. This is very, very important. This is called contact process. This is the main key step here. 2 moles of sulfur dioxide combines with 1 mole of oxygen and forms 2 moles of sulfur trioxide. Okay? And here we use vanadium pentoxide or platinum as a catalyst at 70 temperature and 2 to 3 bar, that is pressure. Very under low pressure we will compress it under 2 to 3 bar pressure. Okay? Sulfur dioxide is oxidized to sulfur trioxide. Right? Okay. And here also, according to Chatalia principle, this is a highly exothermic reaction. Delta H about minus 196.2 kilojoules of heat energy is liberated, highly exothermic. Here also low temperature and high pressure. Low temperature and high pressure. Low temperature and high pressure favors what? Favors formation of or oxidation of SO2 to SO3 according to Lee-Chatalia's principle. Lee-Chatalia's or Lee-Salia's principle, which are explained in the reverse process. See, since it is exothermic reaction, forward reaction is exothermic accompanied with the liberation of heat. Then backward reaction should be endothermic accompanied with the absorption of heat. Initial. When you increase the temperature of above equilibrium, system tends to decrease temperature. How? Which side? Where absorption takes place. Which side absorption takes place? In endothermic side. Backward reaction is favored at high temperature. That's why high temperature is not favorable condition. Next, if you decrease temperature, system tends to increase temperature. How? By shifting equilibrium in that direction where energy is liberated, temperature increases forward side. Therefore, low temperature favors formation of SO3. Pressure at 2T. Total pressure 2 plus 1. It is explained on basis of what? Number of moles. Reactant 3, product 2. Decrease in number of moles. So if you increase pressure, system tends to decrease pressure by shifting equilibrium to the forward direction where number of moles decreases. Right? Therefore, at high pressure, SO3 is favored. At low pressure, it's decomposition, not a formation. That's why, once again here also, low temperature, high pressure favors formation of sulfur trioxide. But once again, according to technically, at low temperature here also sometimes rate of reaction stops. And at high pressure there is a chances of exploding plant. Since SO3 is also highly acidic, SO3 is also highly acidic. If you dissolve in water, it will form directly sulfuric acid, no doubt. But it will form a dense acid fog, which is also not good for the workers in the plants. And sometimes due to high exothermic reaction, the whole plant may explode. That's why high pressure is also not favorable. Therefore, optimum condition for oxidation of sulfur dioxide to sulfur trioxide is what? What are those optimum conditions? The optimum conditions are, that's only, what are those? The whole physicochemical principles. Okay? Optimum temperature of 720 Kelvin, like that of ammonia. Then vanadium pentoxide or platinum as a bar pressure. Okay, low temperature and high pressure, actually high pressure technically I told you, but 2 to 3 bar pressure only pressure is enough to oxidize sulfur dioxide to sulfur dioxide. These are the optimum conditions. Okay, very very important for 2 marks, like that of ammonia by Haber's process. Right? So students, once again, this is also a contact process where we got what now? Third step, final step. What we got? Yes, sir. The next, fourth one here we will write it, absorption. Absorption to form oleum. Oleum. What is oleum? Fuming sulfuric acid. That means this SO3 is not directly absorbed in water, it is absorbed in H2SO4 itself to form H2S2O7, which is called oleum, or it is also called pyrosulfuric acid. Pyrosulfuric acid. 98% concentrated sulfuric acid. Oleum will get. Sir, why not we should not dissolve in water? If you dissolve in water also we will get it, but we get a dense acid fog, that means very dangerous. Those vapors are very dangerous for the persons working in the plant. Okay, they will get a very dangerous disease. They will undergo coma condition. They will suffer from fever first, nausea, giddiness, and coma condition. And also there is a chance of explosion of production plant. Why? Because addition of SO3 to water is highly exothermic reaction. That's why it is absorbed in sulfuric acid to form oleum. Then lastly, okay, that is, this is second step actually, sorry, purification it is not there. Then examination of the red like this only, dilution. That means now this oleum finally H2S2O7 is diluted with the calculated amount of water, desired amount, whatever concentration we need, we can bring out sulfuric acid. 10%, 20%, 36%. 36% concentrated sulfuric acid is the laboratory grade, what we use in the lab, in the practicals. Okay, right. That's about manufacture of sulfuric acid by the contact process. What are the steps? First, production of SO2. Then you have to write this in the examination. Very importantly, these are 1, 2, 3. Then third step, absorption, form oleum, then dilution. If it is asked for 3 marks, no flow sheet diagram, you are lucky. This is about contact process, which is a very very important part of the 16th group. How in 15th group ammonia by Haber's process, nitric acid by Oswald process. Here it's a compulsory. Actually it was a compulsory question, but due to this COVID it has been deleted from your only theory, not for need. I am repeating. Okay? Right. This is completion of manufacture of sulfuric acid by contact process. Now students, after this contact process, now we move on to what are its physical and chemical properties. What are the physical and chemical properties of sulfuric acid? Physical property, you already know this sulfuric acid. Sulfuric acid is a highly viscous liquid. Highly viscous liquid. Very important. Highly viscous liquid. Highly viscous liquid with the high density, specific density 1.84 grams per cubic centimeter. Okay? Right. It is like a oily type, highly soluble in water. If water is soluble to form, okay, that is HSO4 and H3O+. Remember, hydronium ion and bisulfate ion. Further, this bisulfate ion gives the water in form sulfate SO4 plus, right, and H3O+. Here K value is very high, that is 1.2 titration value, and here K value 1.2 titration. Higher the value of Ka, stronger the acid. Higher the value of Ka, stronger the acid. But you know that this sulfuric acid is highly corrosive in its action, high specific gravity, viscous liquid, form the intermolecular hydrogen bonding. associated through intermolecular hydrogen bonding even in the water. Because of that, it boils at a constant boiling mixture. Constant boiling mixture at 611 Kelvin due to intermolecular hydrogen bonding. Very important point to be noted for CET. Okay, right. Then this is it is having both oxidizing property, reducing property, and very importantly dehydrating property. It is a powerful strongest dehydrating agent ever used. After that, phosphorus pentox the second dehydrating agent, but this is the strongest dehydrating agent apart from its oxidizing and reducing properties, and it's called as king of chemicals. Why it is called king of chemicals? Because for various, in all industry, it is commonly used as solvent to form so many compounds. Like for example, what we call it as chemical fertilizers, okay, and industrially important compounds, and in the laboratory. It is used as strong acid, highly corrosive. It is called as king of chemicals. And generally in Hindi it is called as Teza. Okay, it should be available in the gold merchant shop. Okay, in the gold merchant shop it is traded as under the name Teza. Okay, and I also see Teza picture also. That's only, even if it contacts with the skin, it will even melts the bone also. Highly corrosive, right? That's about very important information regarding sulfuric acid, and it is called king of chemicals because of its reactiveness and its wide application in the industry to form many chemical compounds. Industry important compounds and another important compounds. Okay. Coming to chemical properties. Chemical properties of sulfuric acid. What are the chemical properties of this H2SO? The sulfuric acid generally reacts with the metal halides and forms M2SO4, metal sulfates and 2 H's, right? 2 H's. And generally this X may be chlorine or nitrogen. That means halogens and nitrogen. Metals may be sodium, potassium. Metals may be M, may be sodium, okay, potassium, or even anyone, sodium, potassium, barium, any metals, right? Calcium. All they form the respective metal sulfates along with their respective halides, right? Okay, that means chlorine, nitrates. That's about the first reactivity with the metal halides. This is one problem. Secondly, dehydrating property. Apart from this is having very important dehydrating nature. Dehydrating nature of sulfuric acid, very important. As for theory is concerned, it's a compulsory question. Dehydrating property. In your NCERT textbook, they are given sucrose, C equal S22O11. Okay, this is the diacetyl, which you are going to study next in biomolecules. The sucrose equal S22O11. When it is treated with sulfuric acid, it acts as dehydrating agent. It charges. It is called as actually sugar. What we use sugar in our day-to-day life, sakkare anta antarala, chini, right? In Hindi it is called chini. Chini is कहते हैं उसको हम sugar. It's called sucrose. Actually, it is made from what? Cane sugar, because it is prepared by what? Sugar cane juice. That's why it's called cane sugar. Okay, that's what charge the sugar to black carbon. We take in a test tube sugar and add sulfuric acid and shake it and leave it for 2 to 3 minutes. Whole test tube will become black color. Due to what? Black carbon. That means it charges sugar to black carbon and dehydrates water of hydration as elements from the compound. Such a dehydrating property is having. See, it will remove 11 moles of water of hydration. This is the reaction like actually. Explain dehydrating property of sulfuric acid with an example. Very important. VVRV. Very important for theory. 2 marks, pakka question. If they ask you to write this thing. Charge the sugar to black and removes water of hydration of water. We show like this only because in NCERT it is not given clearly. You have to write like this only better. Okay. 12C plus H2SO4 dot H2O means this hydrogen and oxygen are removed in the form of water of hydration and attaches to sulfuric acid in the crystal form. Right? Okay. Now this is called as what? Charring of sugar. This process of converting white sugar into black carbon is called charring of sugar. If that is the question, what you will ask, explain charring of sugar. Like nothing but it's a dehydrating property of sulfuric acid only. Remember. Okay. Not only this, another dehydrating property also can give. It will dehydrates not only this, even oxalic acid and formic acid. If you take formic acid, it charges to form CO carbon monoxide to liberate carbon monoxide and water of hydration H2SO4 H2O. Formic acid to liberate carbon monoxide and reduce water of hydration. Oxalic acid COOH dicarboxylic acid also charges CO and CO2. CO2 and H2SO4 dot H2. Actually, these are the three important chemical reactions to show the dehydrating nature of sulfuric acid. Formic acid to carbon monoxide and oxalic acid, dicarboxylic acid called oxalic acid. H2CO4 can be done structurally like this. Okay? Liberates carbon monoxide and carbon dioxide and removes water of hydration from the elements of water of molecule. Right? Very important for CET, Karnataka, KCET, so many times repeated. Right? So that's about dehydrating property of sulfuric acid. Apart from this dehydrating property, let us move on to lastly oxidizing property. Oxidizing property of sulfuric acid. It's a powerful oxidizing agent and it will dissolve most of the metals and give sulfur dioxide gas mainly. But not only reacts with metals, even it also reacts with the non-metals. Let us take for example oxidizing properties. Oxidizing property of sulfuric acid. What are those? First one, copper, carbon, sulfur, metal, two non-metals, and even we can write more than enough. With concentrated sulfuric acid, not diluted. With the diluted, they will produce hydrogen, but with the concentrated, it will produce SO2. That's the difference. Sulfur dioxide gas and water. There only hydrogen. So metal dissolves in concentrated sulfuric acid form copper sulfate, sulfur dioxide, and water. Remember. Okay, 0 to plus 2. Oxidize this copper to copper sulfate, reduces itself to sulfur dioxide. So balance the equation to H2SO4, 2H2O and 2SO4. That's it. 4, 6, 2, 4 are 8. Sorry, already it is balance. Okay. Right. 4, 6. That is it. Now it's balanced equation. This is one equation. Then the same way, it also reacts with carbon. Sulfuric acid will get converted to carbon dioxide, sulfur dioxide, and water form. These are common products. SO2 and H2. Right? Carbon is able to set 0 to plus 4. That is oxidized. Once again, plus H2 plus 2. Here also same thing, 2H2SO4, 2H2O. Okay, since sulfur 2 and here 2H2. 4 plus 2, 6, 8. Oh, then very interestingly, sulfur elemental state with H2SO4 concentrated, not dilute. I am repeating, concentrated short form it is. Here also S is also oxidized product. Another SO2 is also reduced product, remember, and H2. Very interesting to this. So 2H2SO4, right? 2SO2, 2H2. So you can also written as SO2SO2, 3SO2 plus 2H2. Right? So this is how sulfur will get oxidized to sulfur dioxide, SO2 plus, and reduced given to sulfur dioxide plus with 2 plus 2. That means here oxidized product and reduced product both are sulfur dioxide. That's why I written first diagonal, then compounds. Or I can write this also. Okay? These are very important for CET purpose, especially CET purpose. So that's about completion of physical as well as chemical property. So remember students, here in sulfuric acid just did one dehydrating nature, PUC for 2 marks. Then base oxidizing properties anyway, if asked for 3. But for CET these are important. Copper to copper sulfate, carbon to carbon dioxide, sulfur to sulfur dioxide. Over and down. Okay? Now lastly, what are the oxo acids of the sulfur? Oxo acids. Okay, how you have studied oxo acids of that is phosphorus, the same thing here. Oxo acids of sulfur. Oxo acids of sulfur. Okay guys, what are these oxo acids? First one, sulfurous acid. Sulfurous acid, H2SO3. H2SO3. See here. Here, with this sulfur is an expanded octet, double bond. Okay. OH, right? And another one, double bond. One bond. 2, 4, 6, 8, and this is 51. Like this, this is having one lone pair of electron, and here oxidation state is +4. This is one oxo acid which contains lone pair. Very important for CET, KCE. So many times asked given for me. Okay. Then secondly, sulfuric acid. See, this will come to know, you will write very easily. If you know chemical bonding, Lewis dot formula. See, sulfur having 6 electrons now. 1 will share here, another will share here, 2 will share with this oxygen, right? That's why 4 are over, then remaining one lone pair. Like that. Now, if you know this, next one is easy. Sulfuric acid, H2SO plus 6 oxidation state. See here, sulfur, right? Now this has been replaced by double bond oxygen atom, OH and OH. Remember, this is diazine. Why not 2 OH? This is also diazine. Above one. Okay, 2 OH. But it is containing one lone pair, here lone pair are oxygen. That is can be taken by oxygen. Right. After sulfuric acid, okay. Can write dithynous acid, H2O3. Dithynous acid, H2O3. See here. Yes, double bond yes. Okay. OH, and double bond. H2. 1, 2, 3, 4. See, 1, 2, 3, 4, 5, 6. Expanded octet, definitely. Right? This is also diazine. Diazine is the nature. These are the first 3 oxo acids: sulfurous acid, sulfuric acid, dithynous acid, H2SO3. Like this, if you go for next peroxo monosulfuric acid. Peroxo monosulfuric acid, which is called H2SO5. or peroxo monosulfuric acid. Monosulfuric acid, which is called H2SO5. According to structure, its oxidation state is +6. Paradox of oxidation number, which is also called as Carnot's acid. Carnot's acid. Very, very important. For meat. Okay, you will study paradox of oxidation number in first year in redox reaction. According to structure, it is +6. What is the structure? Structure will be like this. See, double bond O, H, and that's only one, right? H2. SO5, 1, 2, 3, 4, 5. This is called peroxide gate. -1, -2, -2, right? This -2 +1, and this is +1. Like this, see. Generally, so these two will get cancelled with these two. Therefore, oxidation state from this structure, it is what? Sulfur is -2, -2, -2. That will be +6. Very, very important. Okay? This is called peroxo monosulfuric acid, Carnot's acid, like this. Peroxo disulfuric acid. Peroxo disulfuric acid. This is also BBBIMP for need purpose. See. Formula is H2SO4. Here, same structure you can write, but this is also called as another name. What is the name, guys? Marshall's acid. Okay, and see here. H2S2O7. Peroxide linkage. SO7. Right, first. Double bond O, right? OH, double bond O, double bond O, double bond O, and like this H2S2O. See, 1, 2, 3, 4, 5, 6, 7, 8. So once again -1, -1. This is called peroxide linkage. Here also this is called peroxide linkage. Okay, and here -2, -2, -2 plus -2, -2, plus. Therefore, both the sulfur atom will have +6 oxidation state. This is also +6. This is also +6. These are called paradox or redox reaction, which you have studied in first. See, these are very, very important for NEET purpose. Compulsory question, definite one question will be there. Then ask me what you write. Pyrosulfuric acid, which is called H2SO7. Very simple. Which is called oleum. H2SO7. Just now you are done. Oleum, 98% concentrated, pure concentrated sulfuric acid or fuming sulfuric acid is called oleum. Okay. And the structure SOS. Very simple. Because you already done SO bond. Only one. Remaining double bond, double bond. Double bond, double bond. And what you write here? OH and OH. Simple. Okay. H2S2O7. 1, 2, 3. 1, 2, 3. This is also important for theory. Important for theory, they will ask you write the structure and decide basicity. Sulfurous, sulfuric, and then direct. For NEET purpose, these are very, very important. Like this, in all these atoms, once again, this sulfur is surrounded by 4 atoms. It is sp3 hydrogens. Okay, students. So this is the last completion of 16 group. See, students, today what I covered: manufacture of sulfuric acid by contact process. Very, very important. Okay, physicochemical principles. Reading. Then dehydrating nature of sulfuric acid. Compulsory question for 2 marks. Right? Then what are the applications of this sulfuric acid? Sulfuric acid, as I told you in the beginning only, it is called as king of chemicals. It is used to prepare various chemicals like nitric acid, okay, phosphoric acid, and chemical fertilizers, especially in preparation of ammonium nitrate, calcium ammonium nitrate, okay, calcium phosphate, okay. Not only this, even it is used as pickling process. Very important. Pickling process means during deposition of one metal over the another metal in metallurgy. To remove the impurities present on the metal surface, just it is washed. Okay, this is called pickling process by using electrometallurgical process. Okay, and in lead storage battery, it is used as important electrolyte. If concentration of acid is discharged, your battery will go away. If it is once again concentration is increased, the battery will work. That's why it is used in lead storage battery. Generally, what we use in the inverters. And older day, that is ambassador cars. Now they have gone, but in inverters we use this for a lead storage battery, which is secondary cell. What we studied in here in electrochemistry, right? Okay, that's about some important applications of sulfuric acid. See, students, in P block elements, uses of nitrogen, right? Uses of generally nitric acid. See, I told you uses of dihydrogen only important example. That too for theory as well as CET I have discussed, but not all the uses are not discussed because you will get confused. This is more than enough what they will teach in the class. Okay, this is a completion of 16th group elements. Right? So students, I hope you are getting this P block elements, because generally students tell, not only you, all PUC second year students will tell P block very heavy, very hard. No, nothing is hard. Okay. See how I taught you. First what? Physical properties. Right. Then what you study? Anomalous properties. Then oxidation state, chemical properties. Then usually compounds. In 15 group nitrogen, here dioxide. In 15 group nitric acid, here ozone. In 15 group once again phosphorus compounds, right? Phosphine, phosphorus trichloride, phosphorus pentachloride. Here allotrop, white phosphorus, red phosphorus. Here rhobic sulfur, monoclinic sulfur. And here compound of sulfur, SO2 and sulfuric acid. Like that. Make comparative study, it will be very, very easy for you. Okay? But one question for theory very important: anomalous property compulsory in 15 group nitrogen, 16 group oxygen, further in 17 group that is chlorine. Compulsory question for 2 marks, either reason or properties. Okay? Once again I will compare you when this whole chapter completes. Right, students? So we will stop today here. So tomorrow's class I will start with the 17th group element. That needs also 3 to maximum 4 periods. And just 2 periods I will complete 18 group elements. Okay? So enjoy the day, don't get bored, and keep faith in yourself. Okay? That's it. Bye. Today we will complete. Bye from PANCHNATH SIR. Thank you.